In this video, we want to learn how we can find limits of functions with the factoring method. The first question is limit as x approaches 3 of x to the 2 minus 8x plus 15 over x minus 3. For finding limits, the first step is to substitute the number. Because in this example, x approaches 3, we substitute 3 for x, and then we have 3 to the 2 minus 8 times 3 plus 15 over 3 minus 3. If you calculate this expression, we have 9 minus 24 plus 15, 0. And denominator is also 0. And we know that 0 over 0 is an indeterminate form, which means that we cannot find this limit with substitution. Sometimes we can find the limits with direct substitution, but in this case, we substituted 3 for x and we get 0 over 0. So we cannot find the limit with direct substitution. So we try to factor numerator, which is a quadratic expression, and then with cancelling the common factor between numerator and denominator, we can find the limit. Hopefully you remember how to factor quadratic expressions. We have x to the 2 minus 8x plus 15. If you remember, for factoring quadratic expression, we put two brackets. In each bracket we put x, and we try to find two numbers whose product is 15, and the sum of those numbers is negative 8. 3 times 5 is 15, but we want the sum to be negative 8, so our numbers should be negative. So we have negative 3 and negative 5. Note that negative 3 times negative 5 is 15. And negative 3 plus negative 5 is also negative 8. So the factored form of x to the 2 minus 8x plus 15 is x minus 3 times x minus 5. So we have limit x approaches 3. X minus 3 times x minus 5 all over x minus 3. If we cancel x minus 3 from the top with x minus 3 from the bottom, we then have limit x approaches 3 of x minus 5. Now again, if we substitute the number for x, if we substitute 3 for x, we have 3 minus 5, which is negative 2. So the limit of this expression when x approaches 3 is negative 2. Let's review the process. First, we substitute 3 for x to make sure that this limit is indeterminate form 0 over 0. Because sometimes with direct substitution we can find the limit, but in this case we get 0 over 0. Now that we know with direct substitution we cannot find the limit, we try to factor numerator and sometimes denominator. We factor the numerator, we get this, and we cancel x minus 3 with x minus 3 from denominator. We get x minus 5. Again, we substitute 3 for x. 3 minus 5 is negative 2. Let me show you another example. Here we want to find limit as x approaches 0 of 2x over x to the 2 plus 4x. Again, we substitute 0 for x. 2 times 0 is 0. 0 to the 2 is 0 plus 4 times 0 is also 0. So denominator is also 0. So this limit is also an indeterminate form. So with direct substitution we cannot find this limit. So again we have to try to factor in numerator and denominator. In numerator we have simply 2x. But in denominator we have a quadratic again expression. Note that between x to the 2 and 4x we have a common term. What is the common term between x to the 2 and 4x? X. If we factor x from these two terms, from x to the 2 remains x, and from 4x we have 4. Now, if you cancel x from the top with x from the bottom, we have limit of 2 over x plus 4 as x approaches 0. If we substitute 0 for x, then we have 2 over 0 plus 4, 4. 2 over 4 is 1/2. So this limit is 1/2. Limit of this function as x approaches 0 is 1/2. Another example. Limit as x approaches 4 of x to the 2 minus 2x minus 8 over x to the 2 plus x minus 20. If we substitute 4 for x, we have 4 to the 2 minus 2 times 4 minus 8 over 4 to the 2 plus 4 minus 20. 4 to the 2 is 16 minus 8 is 0. Denominator is also 0. With direct substitution, we cannot find the limit. We have to try to factor numerator and denominator. In this limit, in numerator and denominator, we have quadratic expressions. We want to first factor this. X to the 2 minus 2x minus 8. First we have to put 2 brackets, x in each bracket. Try to guess two numbers whose product is negative 8 and the sum of those numbers is negative 2. 4 times 2 is 8, but we want negative 8. So one of them should be negative, the other one positive. Which one should be negative? Because the sum is negative, so the bigger one should be negative. So x minus 4 and the other bracket is x plus 2. Try to factor denominator by yourself. Again, put 2 brackets, x in each bracket. What are the numbers that the product of those numbers is negative 20 and the sum of those numbers is 1? Note that we have x is actually 1x. 4 times 5 is 20, but we want negative 20. So one of them positive, the other one negative. Because the sum is positive, so the bigger one positive 5, the other one negative 4. Hopefully you could factor this by yourself. Now look at the top and the bottom. X minus 4 is common, so we cancel x minus 4, and then we have limit x approaches 4, x plus 2 over x plus 5. Substitute 4. We have 4 plus 2, 6, 4 plus 5, 9, so the limit is 2 over 3. Another example. Limit as x approaches 5 of x to the 2 minus 25 over x minus 5. First we substitute the number. Because x approaches 5, we substitute 5 for x. We have 5 to the 2 minus 25 over 5 minus 5. And we have 0 over 0. So for finding this limit, again we have to factor numerator and denominator. In denominator we have nothing to factor, so we leave x minus 5. But do you remember how you can factor x to the 2 minus 25? Here you need an identity. If you remember, we have this identity, the difference of a squares identity. A to the 2 minus b to the 2 is a minus b times a plus b. For example, if you have something like, say, a to the 2 minus 100, we can write this as a minus 10 times a plus 10. Now, in the same way, can you factor x to the 2 minus 25? Note that 25 is 5 to the 2. So x to the 2 minus 5 to the 2 can be written as x minus 5 times x plus 5. This identity is one of the most important identities that you need in this course, in the calculus in general, and in math. This is one of the fundamental and important basic identities. So remember, a to the 2 minus b to the 2 is a minus b times a plus b. And we name this identity difference of squares identities. So that we have a square and between them is negative, so we say this identity difference of squares. Anyway, back to our question. We factored this with the aim of this identity. X to the 2 minus 25 is x minus 5 times x plus 5. Look at the top and the bottom. Again, we have something in common. This always happens. X minus 5 and x minus 5 cancel each other. So what remains? We have only x plus 5 in top and nothing in the bottom. Actually, in the bottom we have 1, but we don't need to put 1 in denominator here. So just x plus 5 in top. Substitute 5 for x. 5 plus 5 is 10. So this limit is 10. Let me show you another example. Limit x approaches 4 of x to the 2 minus 16 over 16 minus 4x. Look at the numerator. You have x to the 2 minus 16. This expression reminds us the square of the difference of a squares identity. But in the bottom, we have 16 minus 4x. This is not quadratic expression. But look at 16 and 4x. Is something common between these two terms? 16, 4x? Probably you can guess 4 is common. Or maybe negative 4 you can factor. Okay, let us start. First, for finding this limit, we substitute 4. Don't forget, the first step is to make sure this limit is an indeterminate form. Otherwise, with direct substitution, we can find the limit. So, plug in 4. 4 to the 2, 16 minus 16, 0. Plug in 4 for x here also. 16 minus 4 times 4, 16. 16 minus 16 is 0. So this limit was also 0 over 0, indeterminate form. So direct substitution doesn't work. We try to factor. For numerator, similar to the previous question, if we use the difference of a squares identity, we can write it as x minus 4 times x plus 4. What about the bottom? You can factor 4 simply. And if you factor 4, you have 4 minus x. But maybe it's a better idea to factor negative 4. And then instead of having 4 minus x, you get x minus 4, and simply you can cancel x minus 4 with x minus 4. So let's do it. So we factor negative 4. And then, if we factor negative 4, what we have in our bracket? If we factor negative 4 from this expression, from 16, we get negative 4. So that negative 4 times negative 4 is 16. So this is right. And because we factored negative 4 from this term, what remains? Only x. But negative 4 plus x, we don't like to write it like this, negative 4 plus x. Instead of writing negative 4 plus x, maybe it's better to write it as x minus 4. This expression is same expression, but usually we prefer this format of writing instead of negative 4 plus x. So, we factor negative 4. And after we factor negative 4, in the bracket, we have x minus 4. Cancel x minus 4 from the bottom with the top. Then you have limit x approaches 4, x plus 4 over negative 4. substitute 4 for x. After you cancel the common factor, the next step is always substitution. Substitute 4 for x, 4 plus 4, 8 over negative 4. So the limit is negative 2. But maybe some of you think that, okay, I should factor negative 4. Maybe when I see this question, I'm simply factoring 4, not negative 4. So let me show you what happens if you factor 4 instead of negative 4. The answer would be the same and nothing changes. So we do this question again, but in denominator we factor 4. So in numerator is same thing, x minus 4 times x plus 4. And in denominator simply we factor 4 and then we have 4 minus x. Now here, some students think that, okay, we don't have anything common between top and bottom, so they stuck here. And they don't know what they should do. But attention, x minus 4 and 4 minus x are almost same expression. The difference between them is that they are negative of each other. Let me explain this to you. Consider 2 minus 5. What is this? Negative 3. Consider 5 minus 2. I switch these two numbers. Answer is 3. What happens if we divide these two? What happens if we divide 2 minus 5 by 5 minus 2? Then we have negative 3 over 3. And this equals negative 1. So actually we can cancel these. And what remains is just a negative. So they are equal. The magnitude of them, the value of them is the same, but they differ by a negative. So same thing is true here. When you have, let's say, a minus b. In denominator you have b minus a. I know they are not the same. Here we subtract b from a, but here we subtract a from b. But you can cancel them in a fraction and you have a fraction. And what remains is a negative sign. So negative 1. So same thing is true here. We cancel x minus 4 from the top with x minus 4 minus x from the bottom. But remember, when you do this, don't forget to put a negative maybe in top or bottom, doesn't matter. I prefer to put a negative here, negative 1 here. So we cancel x minus 4 with 4 minus x, but when we cancel them, because they are not exactly same, a negative remains. And you can put that negative in the top or the bottom. So what happens? Then we have limit of negative 1, or you can simply write negative times x plus 4 over 4 as x approaches 4. Substitute 4 for x. Then you have 4 plus 4, 8. This becomes 8. 8 times negative 1 is negative 8 all over 4, and the answer is negative 2. Compare these two answers. They are same. Exactly, they are the same. And so it's completely up to you which method you prefer. Maybe you prefer to factor negative here and continue like this, or maybe you prefer only 4, but when you factor 4, you have to attention x minus 4 is negative of this, so when you cancel it, cancel x minus 4 with 4 minus x, don't forget to put a negative in the top or the bottom. And as you can see, the answers are the same. Of course, they should be. Let's do another example. In this example, we want to find limit as x approaches negative 3 of x to the 2 plus x minus 6 over 9 minus x to the 2. If we substitute negative 3 for x, we have negative 3 to the 2 plus negative 3 minus 6 over 9 minus negative 3 to the 2. It is 0. And 9 minus 9 in denominator is also 0. So again, we have an indeterminate form, and we have to factor numerator and denominator. In numerator and denominator, we have quadratic expressions, if you think 2x to the 2 plus x minus 6, we want to find two numbers that their product is negative 6, the sum of them is 1, and those numbers are 3 and negative 2. 3 times negative 2 is negative 6, and 3 plus negative 2 is 1. What about the bottom? 9 minus x to the 2. Again, for factoring 9 minus x to the 2, you need to remember this identity. A to the 2 minus b to the 2 is a minus b times a plus b. So we can write it as 3 minus x times 3 plus x. Note that 9 is 3 to the 2, so we have 3 to the 2 minus x to the 2. So we can write it as 3 minus x times 3 plus x. Now look at the top and the bottom. X plus 3 and x plus 3 are common between top and the bottom. So that x plus 3 and 3 plus x are same expression. Between them is plus, not minus. So we can simply cancel them, and then we have limit of x minus 2 over 3 minus x as x approaches negative 3. Substitute negative 3 in the top. Negative 3 minus 2 is negative 5. 3 minus negative 3 is 6. So the limit of this expression when x approaches negative 3 is negative 5 over 6. Now let's do another example. Limit as x approaches negative 2 of 2x to the 2 plus x minus 6 over x to the 3 plus 2x to the 2. If we substitute negative 2, we have 2 times negative 2 to the 2 plus minus 2 minus 2 minus 6 over negative 2 to the power of 3 plus 2 times negative 2 to the 2. If you calculate no expression in top, it is 0, and denominator is also 0. Some students have a little difficulty for factoring quadratic expressions when the number that appears here is not 1. Something like 2, 3, negative 2, other numbers, and needs a little more experience. But before doing this example, let's take a look at the previous examples that we did so far. And let me tell you something that usually you can find in the textbooks, or look at this first limit. In this limit, x approaches 3. What was the factor that cancelled and then we could find this limit? X minus 3. So in this limit, x approaches 3. And what we cancel from the top and the bottom is x minus 3. So keep this in your head. X approaches 3. The expression that cancels is x minus 3. Here, x approaches 0. The expression that cancels is x. X with x cancels. This one was easy. Here, x approaches 4. What is the expression that cancels? X minus 4. When x approaches 3, x minus 3. X approaches 4, x minus 4. X approaches 0, just x. Here x approaches 5. What do you think will be cancelled? X minus 5. So x approaches 5, x minus 5 is the expression that cancels. Again, x approaches 4, and look at this, x minus 4 cancels. Can you see the pattern? Can you guess what happens in general? And in this case, x approaches negative 3. And the expression that cancels is x plus 3. So, in general, what we can conclude, if x approaches a, then we expect to have x minus a in the top and the bottom, and after cancelling that, we can find them. So, for example, if x approaches 10, what do you expect to have common between the top and the bottom? Of course, x minus 10. If x approaches, let's say, negative 6, what do you think? X minus negative 6, so x plus 6, the expression that cancels. What if x approaches negative 1? X minus negative 1, so x plus 1 is the expression that cancels. Now look at this question. X approaches negative 2. So what should you expect to be the common factor between the top and the bottom? X approaches negative 2. So we expect to have x plus 2 common between the top expression and the bottom expression. And why this is important and it's really helpful? Because now when we want to factor the expression in numerator, we know in advance that one of the factors, it should be x plus 2. And only we need to find the other factor. What should be in the second bracket now? Can you guess? We have to put something here that when this multiplies by x, we have to get 2x to the 2. So, not as usual, we have to put x here. We have to put 2x here. And what number should be here? The number is a number that when we multiply it by 2, we have to get negative 6. What is that number? Negative 3. So, whenever you have a limit, when you substitute the number in the polynomial in the top and the bottom, you get 0 over 0. From the beginning, before doing anything, you know one of the factors. X minus this number is that factor. In this case, x plus 2. So we expect to have x plus 2 also in the bottom. Look at this term and this term. X to the 2 is common between them. So we factor x to the 2. And of course, we have x plus 2. We knew this when we started this question now. Okay, look at the top and the bottom. X plus 2 is common. If we cancel x plus 2 from the top with x plus 2 from the bottom, then we have 2x minus 3 all over x to the 2, and x approaches negative 2. Substitute negative 2. We have 2 times negative 2 minus 3 all over negative 2 to the 2. Negative 4 minus 3 is negative 7 over 4. So the limit of this expression as x approaches negative 2 is negative 7 over 4. I hope you find this video helpful for yourself. If you want to see more advanced questions, finding limits with factoring method, but a little more advanced questions, you can watch my other videos. Thank you for watching and see you in the next videos.